Ignition sequence start.
It's been days and still no call from NASA about our mission into space. I was so sure we'd be called for the latest spectacular mission to another planet.
Say, do you think we're being denied because we don't appreciate our home planet? Like we kind of take it for granted?
Well, I sure don't take cinnamon buns for granted. If I can just... Here we go. Ah!
Forget cinnamon buns. We're suited up for space and ready to learn about planet Earth. First big question is, what makes Earth's location in space so important?
Yeah, and how is Earth unique from the other planets? You know, besides the fact that I live here.
And how does Earth work to support life?
Ooh, I have a good one. What makes a cinnamon bun stick? All right, we'll skip that one.
Water. We play in it, bathe in it, grow food with it, and of course, drink it. Atmosphere. It gives us oxygen to breathe, acts as a blanket to protect the earth, and provides wind to blow through the trees. Soil. Full of nutrients for plants to grow. And sun. Providing the light and heat we need to survive. We may take these things for granted, but nowhere else in the solar system do they come together in perfect balance as they do here on Earth. A big system that really works, so life as we know it can survive.
Okay, Malcolm. On our upcoming mission, our space shuttle will need to be like a little Earth floating around the big Earth. We'll need to take a lot of Earth things with us to survive.
Yep. Lots to do, lots to learn. Lead away, oh fearless one. Ow!
On second thought, we'll take this one nice and slow. Think about it, Malcolm. Out of the billions and billions of galaxies in our universe, Earth belongs to just one galaxy, the Milky Way. And out of all the billions and billions of stars within the Milky Way galaxy, there's only one star that is very important to us.
You mean the big yellow guy in the sky?
You got it, our sun. It's the very center of our solar system. And out of the 9 planets and all the other celestial bodies that revolve around it, there's Earth, a smallish, rocky planet, third in line from the sun.
Third place doesn't sound so special.
Are you kidding? Our position in the solar system is special in every way. Because we're 93 million miles away from the sun, which is also 150 million kilometers, scientists say we fall within the so-called life zone.
What does that mean?
That means we're far enough away from the sun to keep water in a liquid state, and that's critical. See, if we were any closer to the sun, like planets Mercury and Venus, not only would everything on Earth melt, but all of our water would completely evaporate. And if we were farther away from the sun, like Mars, all of our water would turn to ice. In fact, Earth is the only planet in the entire solar system with liquid water in any quantity. So you see, our distance from the sun is perfect. We're in the life zone.
Okay, I got it. Third from the sun is where it's at. Do you know how long it takes for light to travel the 150 million kilometers from the sun to Earth? Less than 1 second? About 1 minute? Or 8 minutes? Time's up! Even though in the entire universe nothing travels faster than light, about 300,000 kilometers per second, it still takes about 8 minutes for sunlight to reach Earth. And if you don't think that's very fast, think of it this way. Even in our fastest spaceship, it would take at least 4 months to travel the same distance. No! Stop!
What? What? What did I do?
You're letting all the air out.
Come again?
There's no air in outer space, so we'll have to bring our own supply when we orbit Earth.
Oh, silly me. Here I was thinking NASA would take care of that.
What are you saying? We shouldn't worry about air?
No, of course not. Air is one of the most important elements for our survival here on Earth. Our atmosphere is made up of about 78% nitrogen, which is an important nutrient for soil and plants, and about 21% oxygen, which enables us to breathe. It also contains carbon dioxide, which is what plants use to make food. Scientists divide our atmosphere into 4 main layers. The bottom layer of air is called the troposphere. This is where our weather takes place. The next layer up is called the stratosphere, where many jets fly to avoid the weather. The next layer is the mesosphere, which protects Earth from most meteoroids. As they enter the mesosphere, the high speed and friction builds up such intense heat that they usually disintegrate into a ball of flame. Meteoroids that actually survive this ordeal and reach the ground are called meteorites.
Hey, I guess if you look at the moon, you'll see what happens when there's no atmosphere. All those craters are the result of meteoroids that didn't burn up before impact.
The last layer of our atmosphere is called the thermosphere. It extends for 320 kilometers, or about 200 miles above the Earth's surface. And it's at the top of this layer where space shuttles, satellites, and space stations orbit the Earth.
That's where we're heading.
Of course, we can't see these layers, but they wrap around our planet like a blanket.
Not the kind of blanket that keeps you warm, I guess.
Actually, our atmosphere does keep us warm. It acts like a greenhouse, trapping just enough heat from the sun to keep the Earth from getting too hot during the day and too cold at night. The atmosphere also contains ozone, a form of oxygen created within the stratosphere as sunlight passes through. The ozone layer is 30 kilometers thick, and it acts as a filter, protecting us from the sun's harmful ultraviolet rays.
Provides us with air to breathe, keeps us warm, and protects us from harmful rays. Our atmosphere rocks!
No other planet in the solar system has an atmosphere like ours. But remember, it's not invincible. Human activity has already affected our atmosphere considerably. For many years, chemicals used in refrigerators and aerosol spray cans called chlorofluorocarbons, or CFCs, have been released into the atmosphere. CFCs destroy ozone, and scientists are concerned that they may have actually caused holes to form in the Earth's ozone layer. And the burning of fossil fuels have added increased levels of carbon dioxide into the atmosphere, which may cause Earth to get even warmer than it is now. So it's really important to keep our atmosphere healthy. Without it, few living things could survive on Earth.
55, 56, 57, 58, 59,
Don't
60,
tell me.
61.
You're collecting water for our trip.
I lost count. Yes, water is essential to survive our trip to space, so I'm just ensuring that we have enough.
Huh? I'm almost afraid to ask, but what are you doing now?
Well, most of Earth's water is salty, so I'm just replicating that condition.
But we can't drink salt water. We need fresh water. What's wrong?
I wish you had reminded me of that 50 jugs ago.
Oh, I'm sure we'll find some use for it. After all, you're right. Most of the water on Earth is salt water found in oceans.
It's hard to believe that most planets have no water, except for a few that may have some ice. Earth is just swimming in it, so to speak.
Water covers about 70% of the Earth's surface. However, only a small amount of that is fresh water. In fact, saltwater oceans make up almost 98% of all the water on Earth. Fresh water is found in lakes, rivers, streams, springs, and glaciers, but most of it is locked up in the polar ice caps.
Yikes! Doesn't sound like there's much fresh water to go around.
Well, luckily, Earth works in such a way that our fresh water is constantly being recycled. This process is called the water cycle.
Yeah? How?
It works like this. The sun's heat evaporates water into the atmosphere from the oceans, lakes, rivers, even plants and animals. As the moisture in the air cools, it condenses and clouds are formed. Eventually, the water is released as precipitation in the form of rain, snow, sleet, or hail. Once the water has returned to Earth, the whole cycle starts all over again. In fact, the water cycle never stops.
I'm ready.
The Earth has had the same water throughout its entire history. And for the past 3 billion years, it has been recycled over and over and over. You know what that means? The water we drink today could have once been bath water for a dinosaur.
Suddenly, I'm not very thirsty.
If water evaporates from our saltwater oceans, then are raindrops salty? Let's investigate. You'll need a large bowl, a pitcher of water, salt, a small bowl, a small weight like a marble, and some plastic wrap. Pour some water into a bowl, about a 1 centimeter deep layer. Add a few dashes of salt and mix to create salt water. Next, place the small dish in the middle of the bowl and cover the large bowl with plastic wrap. Place the marble on top of the film and place the bowl in the sun. Return to your experiment in a few hours. You will see that water droplets have collected on the plastic wrap, evidence of evaporation and condensation. You will also have a small collection of water in your dish. Remove the plastic wrap and taste a drop or two of the water in the small dish. What does it taste like? Do you know why the water is fresh and not salty? When the sun warms our saltwater oceans, only water molecules evaporate and escape into the air. The salt is left behind. So, when the vapor condenses and precipitates as rain or snow, the water is fresh, not salty. This is an example of the water cycle.
Everything about our planet is unique. The atmosphere, the abundance of water, even the stuff beneath our feet is unique.
Like my boots?
No, I'm talking about the soil. Only on this planet do you have rainforests, deserts, icy tundra, grassy plains. All these different ecosystems are created by a unique combination of sun, air, water, and soil. And they each support their own plants and wildlife. It's an incredible system.
And it doesn't exist anywhere else in the solar system.
The Earth is always in motion, constantly building itself up, wearing itself down, and building itself up again. Beneath the surface are separate giant slabs of rock called plates. These move very slowly against each other, and as they collide, the surface buckles and mountain ranges are pushed up. New land is also created by the eruption of volcanoes, and as the lava pours out, it cools and adds to the existing landmass. Sometimes volcanoes erupt underneath the surface of the ocean and actually create new islands. Over the years, while mountains are being formed and new land created, they are also being worn away by erosion. Wind, rain, ice, chemicals, and human activity. Erosion is another unique process here on Earth. Other celestial bodies that don't have atmospheres, such as our moon, don't have wind or water to wear anything away. So landforms such as craters, mountains, or even footprints will stay that way forever.
In 1968, Apollo 8 astronauts were assigned a special mission. They were the first to travel to the moon and back. On their journey, they got to see something that no human being had ever seen. Earth rising over the moonscape, looking like a beautiful blue and white swirled marble against the blackness of space.
What I keep imagining is if I'm a traveler from another planet, what I think about the Earth from this altitude. whether I would land on the blue or the brown part of the Earth. You better hope we land in the blue part.
Don't tell me we got the assignment? Now that we appreciate our home planet, we're gonna study Earth from outer space.
No, not yet. I'm just packing so that I'm ready. I've got my jars of air, water. Hey, pass me that bottle.
What is it?
It's my homemade biosphere. It demonstrates how air, water, sun, and soil all work together as a system. Now pass me that jar with the ants. I'm going to add them to the biosphere.
It's empty.
Oh, where'd they go?
Oh, Malcolm!
My name's John Adams. I'm a senior research specialist here at Biosphere 2. And Biosphere 2 is a large glass structure that's located just outside of Tucson, Arizona. Biosphere is a sealed structure. That means that no air can come in, or is there a lot of air going out. What it's like is like a big greenhouse with a bunch of different plants living inside. Inside Biosphere, at the northern end, you have an equatorial rainforest, so it's really humid and moist. Then you come up onto a cliff and you have a savanna region that has grass. Then on the other side of the cliff, you've got a Caribbean reef system, which is the ocean. Then right behind the ocean, you have a mangrove swamp, an area that you'd find, for example, off the Gulf Coast of Florida. And then finally ending up at the very end in a coastal fog desert, a region that you'd find down on the coast of Chile, for example. Now, there are things happening on Earth. You hear some people saying that the Earth is getting warmer, some people say that it's not. But the one thing that we know pretty much for sure is that gas in the atmosphere, carbon dioxide, is going up. And people aren't sure how plants are going to do with increased levels of carbon dioxide. And so what we can do inside here is raise that level of CO2, or carbon dioxide, to what it will be like maybe 100 or 200 years from now, and hopefully get a better idea of what's going to happen before we actually get there in time. And so we're using Biosphere to try to answer some of those questions.
Okay, so Earth has the kind of soil that can support all living things. But I want to know what's going on beneath the surface.
I'll give you a hint. It's some really hot stuff. When the solar system formed over 4 billion years ago, Earth was hot and molten like lava. Over time, it began to cool and harden.
Not all planets can say that. Half of them are just a huge ball of gas and liquid. You couldn't set foot on them if you tried.
So true. But not Earth. Metals such as iron and nickel sank to the center of the Earth, forming the inner core. There's so much heat and pressure within the core that particles of these metals are packed into a solid ball. The outer core also consists of iron and nickel, but in a liquid form because the pressure is lower. The next layer out is the thickest. It's called the mantle and is made of dense rock. And the outermost layer, the one beneath the soil, is the crust. It is a thin layer, like the peel of an apple, made of silicate rock material. Most of the crust cannot be seen, however, because it is covered with water, rocks, sand, and soil. What on earth?
Gravity is a key element of our life on Earth, my friend. I'm trying a little experiment here. By tying these bricks to my feet, I have increased the pull of Earth's gravity on my body. You should really try this. It's great exercise. 1 and 2 and 3. Oh, whoa!
Let me try to explain it to you in a less painful way, Malcolm. Gravity pulls everything toward the center of Earth and keeps everything from drifting off in space. That's why rocket scientists have had to use technology to develop engines powerful enough to break through the enormous force of gravity. The engines used to launch a space shuttle, for example, generate over 7 million pounds of upward thrust. Gravity not only affects us here on Earth, but also affects our entire solar system. It keeps the moon in orbit around the Earth and keeps the planets in orbit around the sun. In 1687, English scientist Isaac Newton figured this out. He said that a planet's motion around the sun is the result of two things: inertia and gravity. The law of inertia states that all objects move in a straight line unless an outside force causes them to change their motion. If planets moved in a straight line, they would pass the sun and keep on going. So Newton hypothesized that some force had to be pulling on it. That force is the sun's gravitational pull. And when inertia and gravity work together, the planets move in an orbit.
Newton was pretty smart. I wonder if he ever tied bricks to his feet.
No, but I think he had a run-in with an apple.
To better understand the purpose of a lunar spacesuit, let's let our friend Andy Astronaut demonstrate the hazards lunar explorers will encounter.
Oh, I got it!
Oh, no, me.
Stanley,
Wait,
I got the phone! Get
give me,
out of the...
give me, hello?
Go,
Hello?
Give it over! Yes! Uh-huh! Right! We've got him! You bet! Oh, thank you, sir! We won't let you down!
Did we get a mission?
A big one!
Yes!
I knew that salted water would come in handy.
What?
Nothing. Hey, let's make sure we've got our facts straight.
Okay, just untangle me first, would you?
Okay.
Okay.
Turn over this
What?
way.
No,
take,
wait,
no,
don't that.
If you take your arm
Stop
and
it.
put it over, don't
Just
turn.
give me that.
Stanley,
Yes.
stop.
So, Malcolm, what makes Earth's location in space so important?
Our position in space falls within the life zone. That means it's far enough from the sun to keep water in a liquid state, but not too far so that it freezes. The forces of gravity and inertia hold the Earth in orbit as third planet from the sun.
Good. We were also wondering, how is Earth unique?
Earth is a unique planet in many ways. It has an atmosphere which contains oxygen and enables us to breathe. It's the only planet with liquid water in any quantity. The land is always in motion, building itself up through the movement of plates and the eruption of volcanoes, and tearing itself down through erosion. And most importantly, it's the only planet able to support life as we know it.
And how does Earth do that? How does it work to support life?
Earth works as a complex system. The sun, the air, water, and soil. All these elements work together to support life. If one element were missing, then the system wouldn't work.
Well, there's no doubt. We certainly appreciate our planet now more than ever and are ready to study it from space.
No. We're just going to the backyard.
Huh? So this is our big mission?
Aw, come on now. At least we're helping create a livable environment for some of Earth's smaller life forms.
You're really stretching it, Malcolm.
Hey, tropical fish need water, salt water. And we're just the guys to give it to them. Besides, we're being paid for each tank we fill up. Next!
I can't believe this.
Oh, come on, Stanley.
Malcolm, this can't be happening.
Well, you know...
Oh, I can't believe this. We're supposed to be in space, Malcolm.
Got plenty to do here.
If you can't beat them, join them.
Cheers!
All right.
Okay, now be careful when you pour it in. You have to do it like,
Oh,
you know what?
all right.
I'm a
Well,
little
this
warm.
feels nice
I'm a
here.
little, yeah, ooh, that's,
Gotta
it's
make the
hot
best.
in this suit.
Ah,
Is that,
what, you got
you know
BO
what?
there?
We can't use all the water. We need to save some for the fish here. Okay.
Oh, I want
Now,
to pour some in.
when you pour it in, don't go too quickly.
Now, how
Otherwise,
are you
you're going
pouring
to
it?
kill the fish.
Okay, we gotta
All
take
right,
care.
pick up your jug.
Tropical fish, you said, right?
Yes, tropical fish.
Okay.
And I need
Is
to-
this sugar?
You know, I told you the salt water would come in handy, by the way.
Oh, that's right. Oh, I thought this is using sugar or flour? What?
No,
Oh, no,
no,
it's
it's
salt.
salt.
Okay.
It's Epsom salt. Yes, Epsom.
Fish like salt. Boy, I hope these spacesuits don't drown. We're not drowning.
Hey, I kind of like the guy
Do they
in
have
the
oxygen?
spacesuit in the tank there. Don't you think it looks like me? I have a Malcolm action figure.
Oh, no, I think it's actually a Stanley.
Malcolm to the rescue.
It's a Stanley action
It's
figure.
a Malcolm action figure.
That's right. Yeah, all right. We both have an action figure.